A single dairy cow produces about 150 pounds of manure a day. On a farm with a few thousand cows, that waste used to be just a smell and a problem. Now, on a growing number of farms, that same manure is sealed into an airtight tank and turned directly into electricity. The technology is called anaerobic digestion, and the idea is simpler than it sounds. Manure is pumped into a large sealed tank with no oxygen inside. Naturally occurring bacteria break the waste down in stages, first turning complex organic solids into simpler compounds, then into acids, and finally into methane gas. The whole process takes a few weeks under stable temperature and constant mixing. And instead of that methane leaking into the atmosphere the way it would from an open manure lagoon, it gets captured and piped out as fuel. There are two main designs in use today. Covered lagoons are essentially large earthen ponds sealed with a floating cover, cheaper to build and common in warmer climates where the bacteria stay active without extra heating. Complete mixed concrete tanks cost more upfront but include heating coils and mechanical mixing, which lets them run efficiently even through cold winters and produce more gas per cubic meter of manure processed. That captured gas, called biogas, is usually 60 to 65% methane, and farms have a few ways to use it. Many burn it in an on-site generator to produce electricity and heat, enough to run the farm itself with surplus sold back to the grid. A large dairy with around 1,500 cows can produce 300 to 400 cubic meters of biogas a day, enough to generate roughly 1,200 kilowatt-hours of electricity, or to displace about 80 gallons of diesel fuel. Other operations upgrade the biogas further, stripping out impurities until it matches the quality of natural gas, then selling it directly into the pipeline network as renewable natural gas. None of this is cheap to build. Installing an anaerobic digester system typically costs $800 to $1,200 per cow. And for the larger systems built specifically to produce pipeline-quality renewable natural gas, total project costs can run past $4 million. That is a serious capital commitment for any farm. But with electricity sales, renewable fuel credits and carbon credits combined, a mid-sized operation can bring in $70,000 to $100,000 a year from a digester. And most projects pay for themselves within 3 to 7 years, especially in regions with strong state or utility incentives supporting the technology. Financing structures vary widely too. Some farms take out long-term loans against projected energy revenue. Others partner with third-party developers who own and operate the digester while paying the farm a fee for the manure and land. And a growing number rely on state clean energy grants or federal rural energy programs to cover a meaningful share of the upfront cost before a single kilowatt-hour is sold. Anaerobic digestion only makes financial sense at a certain scale. Below a few hundred head of cattle, the fixed cost of tanks, generators, and gas handling equipment is hard to recover, which is why digesters cluster on the largest dairy and hog operations rather than small family farms. Some smaller producers get around this by joining regional co-ops that pool manure from several nearby farms into one shared digester, splitting both the construction cost and the eventual revenue. Even on large farms, digesters need consistent staff attention. Tanks must stay at the right temperature, gas leaks have to be monitored constantly since methane is both flammable and an asphyxiation risk in enclosed spaces, and equipment failures can shut down power generation for days at a time. Running manure through a digester does not make it disappear. What comes out the other end is called digestate, and it is arguably as valuable as the electricity itself. Digestate is rich in nitrogen, phosphorus, and potassium, which means it can be spread on fields as a fertilizer, cutting down how much synthetic fertilizer a farm needs to buy. It also has far less odor and fewer pathogens than raw manure, since much of that gets broken down or destroyed during digestion. Some farms even separate the solid fraction out and use it as bedding for their own animals, closing the loop even further. Separated digestate solids also compost faster than raw manure and produce noticeably less runoff risk when stored, which matters in regions with strict water quality regulations near rivers and lakes. The climate case for digesters is bigger than any single farm's energy bill. Methane is a far more potent greenhouse gas than carbon dioxide over the short term, and manure lagoons left to decompose naturally release exactly that. According to a World Biogas Association report, widespread anaerobic digestion adoption could cut 10 to 13% of current global greenhouse gas emissions. That is why digesters increasingly show up not just as a farm income strategy, but as a genuine piece of climate policy, with utilities and governments offering incentives specifically to get more of them built. What started as a waste problem on livestock farms has become a genuine power source, one that turns a smell nobody wanted into electricity, fuel, and fertilizer, with a lot less methane escaping into the air along the way.